So Granite Penguin asks, where is image management done and where are the images stored?
So the management itself would be done however you choose to manage container-like images, right? So if you've already got this cool CI/CD pipeline that you're using to build container images with, you can actually drop image mode images right in that same pipeline. In my experience, there were a few little snags that I had to get around just because of the way RHEL is managed versus the way a container is managed. And there's, of course, some slight differences in how a container file gets written, although they're largely identical. But there's different ideas, different paradigms you need to put in place because you're doing things like you don't have to register a container, but you have to register a RHEL image mode system, right? And there's ways to do that in that build pipeline. And then where do the images get stored? Well, you might see this coming, but they get stored in a container registry, the same as you would any other container image. And that's exactly what we did. Sorry, go ahead.
So I think what Granite Penguin was getting to is like when we did the download of the new image, where did that go?
Oh, that went to basically it went to the file system of the system that we're running on, right? So the system we applied the update to, the file system tree gets written out, and like I said, it's like a dual tree mechanism, like you'd see with RPM OS tree, for example, or some other like edge device use cases where they had that two different tree mechanisms. It writes out a new tree with all of the stuff that was in the container file or in the container image. Of course, merging etc and not replacing var, like I said earlier. And then when you reboot, all it says is switch those trees.
So it's essentially like A/B imaging, right? Or you
right.
pull down your B image, you switch to it, and then later on you can replace your A image with whatever the next image after that is. Right. And you just kind of oscillate between the two. Nate, I cut you off. You were mentioning container registry, which I think is actually a really cool management thing. Can you finish your thought on that?
Sure. I mean, that was kind of the end of the thought, but they're stored in a container registry like you would any other container, which means you can do things like apply tags to them, say these are my dev and these are my stage and these are my prod systems, or you can apply date stamps, for example, like this is when we applied our Q2 patches and these are our Q3 patches. And of course they respect the same latest tag like you would with any other container image. So you can just say I want this machine to track whatever the latest is, and whenever it gets updates, right?
And that's actually what you're doing when you did that Bootc check at the very beginning and it said you had an updated image. You were checking the registry, which said you had a newer container available.
Right.
And showed you what was there. The other really cool thing about registry is, well, first, let me say, you will be storing containers essentially in your registry that are multiple gigs in size, right? Because they're the entire operating system image. But, you know, if you've worked with virtual machines in the past, trying to get new images can be problematic, especially across things like implementations or subsystems or clusters or like however you have it organized. But container registries are pretty well understood of like how you configure your machine, and then you just pull a updated container out of a registry. And you can do that regardless of things like cluster or storage backend or like all these other things. So from a, how do I get this machine to another developer or another environment, all of a sudden those questions become a lot easier.
Yeah. And the really neat thing is, you know, I built this specific use case. The developer has pushed updates to the registry. That developer may not have been developing against a physical machine. You can actually run these things inside of Podman on your local desktop. So if you make changes to it, now obviously it's not going to do the full bootable mechanisms inside of Podman, but you could test to see if the container comes up. You can test to see if your changes worked right inside of like Podman desktop or direct Podman on your laptop, right? Which I think is also a really cool thing, which previously we've done with like, what was that? Vagrant, I think, was the thing that would let you spin up and spin down systems locally so that you can do some testing before it goes on to actual physical machines or actually into the actual infrastructure. This is kind of like that, except I think simpler, easier to deal with.
Yeah. And so on that note, like one of the things that we're trying to do with the design of Bootc and image mode based images is you've got it in your registry. And if you pull it into a container tool like Podman or Podman Desktop, it works like a container. And if you instead deploy it on a virtual machine or bare metal, it works like an operating system image. The container side piece, like you pull it into your container applications or container management, whatever's, the kernel and all those files are still there in its file system, but it's not being run, right? It's just using the application layer stuff. Whereas if you put it on a virtual machine or bare metal, it's got to boot into the kernel and have all those other mechanics of a system. And those are already present in the image, and now they can be used on that bare metal or virtual machine.
There was a very nice leading question in the chat just a second ago from Granite Penguin. Does this work to do major release changes? And this is what I was hinting at earlier during the critical path. And the answer is it can. You can do a bootc switch, which is a command we're not going to touch on today, but it's basically how you tell it to switch to a different container image, maybe even from a whole different registry. And you can do a bootc switch between a RHEL 9 image mode system and a RHEL 10 image mode image. Now, obviously, all the caveats apply about moving major operating system versions, right? If there's library differences or whatever that your application depends on, that's stuff you're going to have to test before you switch. But presumably, you did all that before you pushed it to your registry and were ready for the move. But yes, you can move from 9 to 10, for example, using bootc switch.
But I would go even a step further and say that it's actually safer to do it this way, because when we use tools like Leap and it's doing individual RPM upgrades, there's really not a way to downgrade yourself back to the old version again. Whereas with bootc, you simply tell it to boot the previous image and reboot. And now you're back to your RHEL 9 image that you had initially. And we actually have a little like quick walkthrough of this. And I can share it in the chat.
Oh, the demo, right. Cool. So I do have more to show. We have any other questions that I missed that maybe we want to talk about?
I think we covered. So somebody asked about, can it be done bare metal? I think we covered that. Nest D said that was asking about compression, a variety of other things for edge computing use cases. So the actual thing that's making the bootc and image mode image is RPM OS tree, which is the same thing that we've been using for RHEL for the edge. The big difference between them is while the file system and like image management kind of works in a similar way, RHEL for the edge also has some automated validation testing at boot time and will automatically switch you back if there's a failure, as well as a bunch of technology to do image transfer with like intermittently connected systems or like, that kind of stuff that's not currently present in just image mode, right, natively. So there are these additional technologies that are included in edge deployments that are not just native to image mode of bootc, but are included in some additional Red Hat products designed for edge use cases. But yeah, I think that's about it.